right, hello geometry. We are doing our last video about angles involved with circles. So we're actually going to cover two other types of angles today. Both are pretty simple. You'll catch on to both of them pretty easily. Um, but let's start off with a warm up just to refresh our angle properties that we've dealt with before. Um, so let's see, what is the measure of angle B? This should have been your little warm up that you did a moment ago. Or no, sorry. This one was your warm up that you did a moment ago. But if we want to solve this, okay, we know that this is an inscribed angle. It's an inscribed angle because my vertex is on the edge of my circle. It's in my circle. So in order to solve for this, we need to figure out what is my intercepted arc that I have. Well, the intercepted arc, we can see that we can easily calculate because we know the full circle is 360. So we can do 360 minus 99 minus 105, and that is going to give us our intercepted arc. So 360 minus 99 minus 105 leaves us with 156. So we know 156 is our intercepted arc. And then we just have to think, okay, what's our rule for intercepted arc and inscribed angles? Well, inscribed angles are always half of their intercepted arc. So all we need to do is just take 156 divided by 2. So 156 divided by 2 leaves us with 78 degrees. So 78 degrees is our angle. I apologize also as well. I am recording this at home, so handwriting won't be superb today. From here, we have our second type of angle. So this is an outside angle. We learned previously that our outside angles was our major arc, the larger arc, minus the smaller arc, the minor arc, divided by 2. So it was our largest arc, which in this case is 144, minus the smaller arc of 82. And then we took whatever that answer was, which in this case, 144 minus 82 is 62. And then we'll divide that answer by 2. So cut it in half, and that is our angle. So 62 divided by 2 is 31. So our angle measure that we have is just 31 degrees. So big arc minus small arc divided by 2. Now, we actually have that same type of angle. We have an outside angle on this third picture here. This actually might have been a one from your practice the other day. But we can see we have this right angle in here. So if this is a central angle, we know central angles are always equal to their intercepted arc. So my small arc down here, this small little green arc, if that's 90 degrees from a right angle, this would also have to be 90 degrees. Well, if this is 90 degrees, I know because this is an outside angle, it's major arc minus minor arc divided by 2. So I need to figure out what is this major arc. Well, if I just if I'm looking at everything besides that 90 degrees, I just have to think, what's 360 minus 90? Well, 360 minus 90 is going to leave me with 270. So I have 270 degrees for this major arc in blue. I have 90 degrees for my minor arc in green. So I can do 270 minus 90 divided by 2. Now, 270 minus 90 is just 180. Divided by 2 leaves us with 90 degrees. So our angle in here is 90 degrees. Easy enough. All right, so that was sort of review over things we talked about already this week. Let's jump into something new. So we're going to talk about a new word today. So just like how we talked about tangent lines the other day, we're going to talk about what chords are. So a chord, if we look from our two pictures, a chord, we have this line that touches one edge of my circle to another, a line that touches one edge of my circle to another, and then I have this not chord, which touches from the center outside of my circle to the center. So a chord specifically is a line that goes across your circle, but does not pass through the center. So if we look at both these chords, do not pass through the center, while this one here passes through the center. If as soon as it passes through the center, it stops being a chord and becomes a diameter, because we know the diameter is all the way across our circle that passes through the center. But these chords are just any line that draws across my circle that doesn't pass through the center. Now, if I draw two chords, what's similar and different about these pictures? Well, something that's similar is that both of them make these vertical angles. So I have these vertical angles there. We know vertical angles are always true, and that shows up in both of these pictures. Now, what's different about them, though, is that this one passes through my center. So these are both diameters, and these are chords because they do not pass through the center. So we know that these are central angles, This forms central angles, or two central angles. Central. Because they do not pass, or they do pass through the center of my circle, while these angles here are not central angles. So we call these two chord angles. Now, the reason being they're called two chord angles is just because they're formed out of two chords. I have two lines that are both chords, and they form these angles. Now, what we remember about vertical angles, though, is that vertical angles are always the same. They're congruent to each other. So that means these two central angles are congruent. These two chord angles are always going to be the same. So if I can solve for one of these angles, then I know what both of them are. So essentially, we only have to solve for one of these angles whenever we're solving this problem, because that answer is going to be the exact same for both problems. So let's look at some pattern. Let's look at some pictures and see if we notice any patterns. So what do you notice? Why aren't these same as central angles? Well, one, we know they're not the same as central angles because they're formed as two chords. Their vertex of the angles are not in the center of their circle, because our center would be like somewhere about here and somewhere about here and somewhere about here. So as long as the vertex is not in the center of the circle, they aren't central angles. They're two chords. Now, what else do we notice? We see I have an angle of 50 degrees. I have an angle of 30 degrees, or I have an intercepted arc of 50, an intercepted arc of 30, and then I have 40 degrees as my angle. I have an intercepted arc of 80, an intercepted arc of 20. I have 50 degrees as my angle. And then lastly, 150 are my two intercepted arcs, and 75 are my angles. So you might be able to catch on to the pattern just by looking at these, that we see that 50 plus 30 equals 80. Well, what's half of 80? Half of 80 is just 40. What's 80 plus 20? 80 plus 20 is 100. And what's half of 100? Half of 100 is 50. And then same idea with this one. 100. Sorry, this handwriting is so bad. Is 50. Is 150. And then half of 150 is 75. So our pattern we're picking up that we notice for each of these is all we have to do is add our two intercepted arcs that are intercepted by both of our different angles, add them together and divide by 2, because the inside angles are always going to be the average of both of those. We add them together, divide by 2, that's the average. And so the average of both those angles, and once again, they're vertical. So if this is 40 degrees, this one's also 40 degrees. If this is 50 degrees, this is also 50 degrees. If this is 75, this is also 75. So as soon as you solve for one, you have solved for both of them. So let's try to answer some of these. Let's see if we can solve some of these problems. So I have two intercepted arcs, 160 and 130. I know all I have to do is take both those arcs, add them together, and then divide by 2. So 160 plus 130 is 290. Divided by 2 leaves me with a solution of 290 divided by 2 should be 145. 145 degrees is my answer. What about this one? I see I have two arcs of 135 and 75. If I add 135 and 75, I get 210. Well, all I have to do is divide 210 by 2, and that leaves me with 105 as my two angles. And then lastly, all right, this one's a little bit trickier because they were solving for an intercepted arc rather than solving for our piece. But the thing is, I can solve this because I can figure out what is this angle right here. I can kind of work. We can figure this out to be able to work backwards and solve our answer. Because I know that these two angles are supplementary. They are linear. So I know I can solve for this because they form a line. That means they add together equal 180. So if I take 180, let me type this. I am terrible at writing with this mouse. So if I do 180 minus 102, that leaves me with 78 degrees is the answer essentially of my interior angle. So this is 72, or this is 78, I apologize, and this is 78. So I know that 95 plus some angle x divided by 2 has to equal 78. Well, how can I solve for this? First, it's just like solving an equation. First thing we need to do is we need to get rid of that denominator. So I don't want to have this divide by 2 here. So I'm going to multiply by 2, use my inverse operation. So I can get rid of this denominator and I can easily simplify this. So if I multiply by 2, on my left side I have 95 plus x left over. On my right side I have to figure out what is 78 times 2. Well, that just gives us 156. Now all I have to do is inverse my constant or coefficient. No, my constant value, I apologize. And that will give me minus 96. So 156 minus 96 leaves x to equal just 60 degrees. So 60 degrees is our intercepted arc and our answer. If we wanted to check our answer, all we had to do was do 95 plus 60 divided by 2 and make sure it equals 98. Or 78, which should be good. Oh, I subtracted 96. I apologize. I wrote the wrong numbers. This should be 95. 95, 95. So this should be 61 is our angle, not 60. I apologize. All right, moving on. Why is the measure of CDE incorrect? So we are looking for the measure of CDE. So why is this angle 40 degrees incorrect? Well, if we look, what are our two intercepted arcs? My two intercepted arcs is 40 and 80. Well, 80 and 40 together give us 120. And we know we take that value and divide it by 2. What's half of 120? Well, half of 120 should be 60, not 40, because this is not a central angle. If our angle was here and intercepted that arc, then it would be 40 degrees because this is a central angle. But it is not a central angle because we see our vertex is not at the center. So this is just merely 60 degrees and not 40 degrees. All right, last one. This one's a little tricky. So we have our outside arc of 3x plus 30, our other intercepted arc of 30, and then my angle inside is x plus 50. So we need to create an equation in order to help us solve this. So I know it's my two intercepted arcs of 3x plus 30 added together. So 3x plus 30 and my other intercepted arc of 30. Both these added together and divided by 2 has to equal my angle of x plus 50. So this gets a little tricky. What I can do is looking at this numerator of my fraction, I see I have some like terms up here. I have 30 and 30. I know 30 and 30 can just be combined to a single set of 60. So I have 3x plus 60 in the numerator divided by 2 equals x plus 50. Now, once again, whenever we're trying to solve these fractions or whenever we're trying to solve these equations and we have these fractions, it's easiest just to get rid of that fraction first. It's easier just to multiply by 2. I don't want to have this 2 in my denominator, so I'm going to multiply by 2 to cancel this out. Just to get rid of it. But remember, if I multiply one side by 2, I have to multiply the other side by 2. And that means everything on this other side is getting multiplied by 2. So I have to distribute that 2 into my x and distribute that 2 to my 50. So my left side is just going to be my numerator, which was just left over 3x plus 60. My right side is 2 times x, which is 2x, and then 2 times 50, which is 100. So I have 3x plus 60 equals 2x plus 100. And this is an easy 2-3-step equation that we can solve. I'm going to inverse my 2x to get my variables to be together. So subtract 2x, and I get this it would be a single x plus 60 equals 100. And then all I need to do from there is subtract 60. Subtract 60, and x equals 40. Once again, if you wanted to solve, you could plug x back into these. So it'd be 30 degrees. This would be 40 plus 50 is 90 degrees. And this would be 3 times 40, which is 120, plus 30 is 150. So we have to think, okay, does 150 plus 30, that gives me 180. 180 divided by 2 is 90. So we know this checks out. We know this works. So we know we got the right answer. All right, so those were our two chords angles. We actually have one other type of angle we're going to talk about. These ones are really, really simple. These are called a tangent chord. So they're all formed by a chord and a tangent line. So we know tangent lines cross the circle just at the edge of the circle. They hit the circle once. At that same intersection, that is going to be one of our endpoints of our chord. So we see our chord and our tangent line touch at that edge of our circle. Now, what patterns do we notice about these angles? Well, it's here. I look at this large blue arc. I see 260. If I look at the angle that intercepts it, I have 130. I have this red arc of 100, and I have its angle of 50. I have this arc of 160, the angle of 80, 200 and 100, 220 and 110, and 140 and 70. So I'm pretty sure you guys probably picked up the pattern, but these are pretty much exactly the same as inscribed angles. All you are doing is taking your arc, dividing by 2, and that's going to give you your angle. So like 260 divided by 2 is 130, 100 divided by 2 is 50, and so on for all of them. All you're doing is looking at what is that big intercepted arc that I'm opening out towards that goes from one side of my chord to the other side of my chord. And I just need to take that value divided by 2, and that's going to be my angle that I have. Now remember, this is the entire angle in here, so its angle kind of extends out of my circle because it's that tangent line. So let's see if we can solve some of these. Really quick flashback to inscribed angles. So we remember inscribed angles are always half of our intercepted arc. So if I take 100 divided by 2, it gave me 50. This is the same idea. This is really just an inscribed angle. It's a fancy inscribed angle because my inscribed angle, rather than having both my lines be chords, I just have one of them being a tangent line instead. So I'm just sort of taking my angle and I'm shooting it outward rather than being only inside my circle. So we're just going to get bigger values typically for these tangent and chords. So let's see if we can solve these. I'm looking for what is the measure of each arc. So I'm actually solving for a bunch of different pieces. If I have 117 as my angle, I know I just need to double it to get my arc. So 2 times 117 should give me 234 as my angle. Well, if I know 234 is this arc, in order to solve for my other arc, all I have to do is do 360 minus 234, and that will give me the rest of my circle, which is 126. What is the value of x in this one? Okay, so we got this intercepted arc here of 130. I know out of my total 360, I could find what this other intercepted arc is. Well, 360 minus 130 is going to leave me with 230. So that means this arc up here is 230. So all I have to do is divide 230 by 2, and that'll give me my angle. So 230 divided by 2 should give me 115. So my angle is going to be just 115. And then lastly, what is the value of x? All right, so I have this arc here of 14x plus 10, and then I have my angle of 8x plus 5. Well, I know the arc is always twice the value of my angle. So, or my arc divided by 2 equals my angle. So 14x plus 10 divided by 2 equals 8x. Sorry, that's supposed to be an x. 8x minus 5. So now, typically, I say, in order to solve this, we want to get rid of that denominator. Luckily, if I look, both of these numbers in my numerator, though, are actually divisible by 2. 14 is divisible by 2. 10 is divisible by 2. So I can actually divide both of these. So 14 divided by 2 is going to leave me with just 7x. 10 divided by 2 is going to leave me with 5. So I can actually reduce that to 7x plus 5 equals 8x minus 5. And then once again from here, this is just a two-step equation that we can easily solve. I'm going to inverse my 7x to get my x's to the same side. So those cancel out. And that's just going to leave me with a single x left over. So I have x minus 5 equals positive 5. And then I just have to add my constant 5 over. So add 5 to cancel that out. Add 5. And my answer is just going to be x. Oh man, that's terrible. X equals 10 is my solution. Once again, I can check this really quick just by plugging 10 back in for x. So if I plug 10 in for x, this is going to give me 10 times 8 is 80, minus 5 is 75. 10 times 14 is 140, plus 10 is 150. And we know 150 divided by 2 equals 75, so we know we are correct. We know our answer checks out. And that is where we're going to finish our video tonight. Sorry if it's a little bit longer. Sorry if the handwriting was a little bit wonky because I did this at home. Let me know if you have any questions. You'll have some practice and a card sort to finish from here. Have a great rest of your day. Wrong button.